starting with the calculator, when you turn it on, you should get a black screen that looks like this. Everybody at the black screen? Okay. We are going to create a new document. Every time we start a new question, we start a new document. So we're going to press 1 for new. It's going to ask you, do you want to save unsaved document? Your answer is no. So you can arrow over and choose no. Okay, but mine starts doing weird things, so I have to click it over here. But say no, then this should pop up. Okay. Now, if you get behind, it's fine. If you have a question, it's fine. Sometimes we hit the wrong key by accident, and then we can't get back to where everybody else is. That's fine, all right? But I'm not going to get frustrated with any of that unless you wait until you're 10 steps behind. That's when I get frustrated, because then everybody's waiting because you waited until you were 10 steps behind. You with me? Yours is what? You got it? Okay. Oh, it might take a while. Sometimes they take a while. They might spin a little while. Is that what it was doing, like spinning, like it was starting up? Yours might go a little slower on mine than some. And there's a few things that will look a little bit different on some of y'all's than on mine. I think all of you have the one that looks like, did y'all have white screens? Okay. So if you have the black screen, if you have a white screen one, then yours, I think, will match what is happening up here. If yours is black on the front, then some things are a little bit different. Not just some of the choices when we hit OK, not how it works or anything. All right, so the first thing we're going to do is add a calculator. So we're all here now? Okay, we're going to click 1. Then we also want to add a graph. So we are going to do, here's this blue control key right here. Okay, and then there's the doc key right here. Above it in blue, it says plus page. So we're going to do control docs, because that means add a page. And we want to add a graph. So we click 2 to add a graph, and we should be here. Okay, so pretty much every time you start, unless we're doing something specific, which we will talk about when we get there, this is how you want to start. Okay, even if you think you don't care about the graph, you most of the time care about the graph. You just don't realize it. So now that we're here, everybody on the graph screen? Okay, we're going to double check some settings, because if you're using one of mine, they may not have been fixed. And we did do this earlier in the year, but because mine does look a little bit different, I forgot to have some of y'all click things, and if you were absent the next day, it may not be okay. So we're here on the graph screen. We're going to press menu. Okay, everybody press menu. Then 9 for settings. This is what your settings should look like. It should say float 6. If it doesn't, you can change it. And remember, this little square thing in this big rectangular thing here is like a trackpad, so you can use it like a little mouse. And you can click on that, and you can make sure it says float 6. And just go ahead and, these 3 things actually don't matter at all right now. But these 2 here, automatically hide plot labels, you want checked, and show axes and end values, click that as well. Okay, and then, before you hit OK, you have down here most likely something that says make default. I'm not sure what the wording is, but make sure that's clicked or checked, or that's what you hit, whatever it is. But make sure you do the make default so that you don't have to do this every time. So if you're on your own calculator, you won't have to do this again. If you're on one of mine, I'm going to go through and make sure they're all done. And then we hit OK, and we're back here. Okay, everybody got those settings done? Because if your float settings aren't right, you might not end up writing down some of the correct numbers, and I don't want that to be a problem for you. Okay, so we're going to check another set of settings. Going to hit the home button to go back here, but we're not doing new. It's not charging at all. Did it come on? Oh, you don't have anything to plug it into. Anybody have a brick that he can use with a USB on it? Oh, your computer does, yeah. Look at that. Works smarter than hardware. Have you already charged this once? Yeah. Okay, well, that's part of it. And how come, see, this is where I get frustrated when I said, is everybody at this screen? Well, I didn't hear you clearly because I kept going. Is everybody else right where I am? Go ahead. Calculator, graph, okay, now you're with us. All right, so here, we're not doing new again because we've already done that. We're going to check the settings. So 5 for settings, 2 for document settings, and this is what yours should look like. It should say float, not float 6, float, okay? Angle should be radian. That's not going to affect us now, but eventually, so we might as well fix it now. Exponential format normal, real or complex should be real. Calculation mode is approximate. That's very important. If it's not approximate, you'll get a fraction every time, which might sound nice, but it gets frustrating when you actually want the decimal, because the majority of the time when we're using the calculator, we actually want the decimal, right? And then vector format. So again, if it all says that, that's great. We're just double checking. If not, fix it. Then click make default if that's your option. If you don't have a make default option, just click OK and it makes it default and you're good. Okay, everybody good with that? And then we should be back here. Everybody with me? All right, good. All right, so now we're going to turn this off for a minute. So Control on turns it off. Mine doesn't actually turn off. That should turn yours off. Okay, and then just put it aside. We'll come back to it in just a minute. We all good? Beautiful. Okay, so this is going on page 51 when we're done. We are looking at function models and how to select the best function model for data or maybe just for information. Sometimes we will have data, sometimes we will just have a problem situation that we need to decide that for. Having the data makes it a little bit better, but this is along the same lines as what we did earlier in the year, but again, we're taking it a little farther. So we're going to look at stamp collecting. So I have these big stamps here that I'm going to move. You don't have them, it's fine. So we're going to look at this data in context, because the first time we did this, it was just numbers, and we just found things, and it really didn't apply to much. But we're going to look at it in context. So we have these 4 people that are stamp collecting, okay? And they're stamp collecting at different rates, but they're all busy on these first 6 days. Okay? They're busy. I don't know if it's like a race or what, but and some models may have restricted domains and ranges. We'll look at that. So we're going to look at Mr. Bean first. So he's got this nice Euler stamp here. I'm going to move him out of the way. And then we're going to decide what function model matches this the best. And we did this with first and second differences early on. Y'all remember that stuff? We were looking at rate of change, and the way in which we explain things was, kind of important there. So y'all get your phones put away too. Earbuds out. Everybody got their phones put away? All right. We need to, when we start looking at this, we need to look at the differences in the days. So basically, this is our X, and this is our Y. So we want to make sure that the X is changing at a constant rate so that we can just do our differences. If these numbers up here in this first row were all over the place, that'd be a problem. But they're going up by 1, so it all changes beautifully and it's just fine. So we're going to look at our differences. So I take 20 minus 50, that's 5. That's 5. 5, 5, and 5. So what kind of function is this? Linear, okay? Why? Anybody tell me why? First difference is constant. Is there another way to say that? Absolutely nothing wrong with that. What does that first difference represent? Slope, good. And what's a fancy way to say slope? Rate of change, good. All right, so this is the first difference, which we can talk about it that way. It's also the rate of change, and it's exactly the rate of change because these each change by 1. Basically, it's 5 over 1, 5 over 1, 5 over 1. If we didn't change by 1, then it's not exactly the rate of change, but we can find it from there. So what this does tell us is that this is linear. And we can explain it 2 different ways. I have seen it explained 2 different ways. I have seen it mentioned two different ways in the AP stuff, so we're just going to make sure that we understand both of them. Do you always have to write both of them? No. In this type of situation, I don't think at this point that you may have to write it at all. I think it would be more in a multiple choice situation, but we want to make sure we understand the wording, because this is where some of the wording really messed with your head, right? So we want to make sure we understand the differences here. So I can say it's linear because, and the first thing I heard was first differences are constant. And another way to say it is that we have a constant rate of change. So two different things that say the same thing basically, right? Just in different ways to explain it. Thank you. All right, any questions about that? All right, so let's look at Mr. Kelly. Move his stamp out of the way. He had a cool math stamp too. Now, can I start by just taking the differences? Do the days look okay up there? Yeah. So I can just start by taking the differences. Oh, but I'm going to do that every time when I have to use the arrow, because I always forget. So this is 2, 4, 6, 8, 10. So is this linear, first of all? No. Can you already tell by looking what it is? Yes. So if I wanted to explain at this point, I could say that it is what? Quadratic, because the rate of change, remember this is the rate of change, just like this was. The rate of change changes at a constant rate. So I could say that. We could also go ahead and do the second differences and then explain it a couple different ways that way. So let's look at our second differences here. This is 2, 2, 2, and 2, right? So that tells me this is quadratic. And I can explain this two different ways, right? I can say this is because the second differences are constant. Okay, because that's true, right? But I need to make sure I understand what the second differences are. And here's where that wording started messing with your head sometimes. This is the rate of change. It is not constant, which means it changes, right? Because in a quadratic or anything that's not linear, the rate of change changes, right? So this is the rate of change. This is the rate of change of the rate of change. Does that make sense to you? This is how the rate of change is changing. The rate of change is changing at a constant rate. You with me on that? And so the other thing we could say is the rate of change of the rate of change is constant. And I know that it sounds weird, but that's what it is. If it's a second difference, the rate of change of the rate of change is constant. That's your second difference as being constant. You with me on that? What questions you got? Okay. So let's go look at Mr. Sully. He's got a cool math stamp too. Move him out the way. All right. So here, can I start by just taking my my differences rather? Yes. Okay. So 13 minus 8 is 5. 30 minus 13 is 17. 65 minus 30 is 35. Let's see. 124 minus 65 is 59. Y'all agree with that? Math in my head is, yeah, I think that's right. And then 89? Is that right? Yeah. Okay. Is this linear? No. Is it quadratic? No. So without doing anything else, if it was a multiple choice question, I could mark out the linear, I could mark out the quadratic easily, because the rate of change is clearly changing, but it's also clearly not changing at a constant rate, right? So it's got to be cubic or higher. So we'll go ahead and do our second differences, which that will give me 12. That will give me 18. That will give me, are you sure that's 59? Yeah. It's going to be 24. And then, okay, so not quadratic, but we already knew that, right? So we go on and subtract again. We're going to get 6 and 6 and 6. So what is this? Cubic, okay? Cubic, which could also be stated as a third degree polynomial, right? So cubic is probably what you're going to see, but it's the same thing, so don't think it's something weird if it's so cubic. So this will really make your brain hurt. This number that is constant, that is the rate of change of the rate of change of the rate of change, right? I know. You just keep going. That's all it is. And so if it sounds weird, you don't necessarily have to understand how to write anything else out about it, but it is the rate of change of the rate of change of the rate of change. We're not going to write all of that, but we could say here, most likely the way you're going to see it is because the third differences are constant. Okay, we good with that? All right, so let's look at Mr. Bruce here. Can I start by just doing my differences? No, because the days are not changing at a constant rate, right? Between days 1 and 3, this is a difference. Oh, see, every time. Between these two, that is a difference of 2. Between these two, that is a difference of 1. This is a difference of 1. This is a difference of 2. And this is a difference of 1. So I have two options here. I can actually find the rate of change by doing the differences in the y's over the differences in the x's, and that's fine. But I might have enough information, and they're not really all over the place. They're just not constant. So here's another thing that I could do. I could look at this and say, all right, well, between 1 and 3 is 2, so I'm good with that. Between 3 and 5 is 2, so I can just ignore that and see what happens. Between 5 and 7 is 2, and then just ignore that and see if that gives me enough information to find what I need. You with me on that? Sometimes it may not, like if you have to do third or fourth differences, you might run out of numbers to do, but let's see what that does for me. So if I subtract these two, because that's a difference of 2, this is 6. The difference here is 6, and the difference here is 6. So what is this? Linear. Okay. Now, when I explain this one, I've got two options. Rate of change is constant, or first differences are constant. But if I'm going to talk about the rate of change, I have to actually show it. Up here, when I did that, and I was able to just say, oh, it's the rate of change, because these all changed by 1, which means it's just they're all 5, and that is literally the rate of change. Here, 6 is not the rate of change. This represents 6 stamps for every 2 days. Does that make sense? So your rate of change is actually 3. The rate of change is constant, but if I'm going to say that, I want to make sure that I show it. You with me on that? So if I didn't want to have to do that, but that's the difference here, then I can just say here that the first differences are constant. What questions you got? We good? All right, so one of the things that we're going to have to do is, yes, if we have tables like this to figure out what the best function is to model our data, but also if we have other types of situations, what is the best function to model the data? So we're going to rewind back to geometry a little bit and talk about these situations. So if I want to find perimeter, so let's say that I'm given some information like the width of the rectangle is x, and the length is 6 more than the width. So this would be x plus 6, right? How do you find the perimeter of literally anything? Add up all the sides, right? Are there formulas for some things? Yes. Do you have to use those? No. Okay. So for perimeter, and it's a capital P, let's talk about why. Bianca, you with us? Let's talk about why, because it is a calculated value. A lowercase letter usually represents some type of information you just kind of pull off and plug in. If it's a calculated value like perimeter or area or something like that, then it usually is represented by a capital letter to kind of tell you that it's something that's calculated. You with me? Just little differences there. All right, so I add up x plus 6, and then I could double that, but again, you can just add up all the sides, plus x plus 6. We don't even need to simplify that. I can tell by looking that when I do simplify this, this is just a linear function. Okay? Just linear. So then if I have area, so let's say that we have, like this is a framed picture. So the picture is a 6x8 picture. And then the frame is the same width all the way around. I don't know what it is, but I know that it's the same all the way around, so I'm going to call it X. Okay, so the width all the way around, these are X all around here, right? So then if I want the actual dimensions of the picture frame itself, the outside of the picture frame, what can I represent this length with? What little expression would that be? Can you give me a straight up number right now? No, because we don't know what the width is, right? But what could we write to represent it? Okay, 8 plus x plus x, because I got one on both sides. Very good. So I can really do 2x plus 8. Yes? Gael, you with us? Then what would I represent this as? 2x plus 6. Very good. Okay. Everybody okay with that? So that means if I want to find the area of the whole thing, area, capital A, is equal to 2x plus 8 times 2x plus 6. And without actually simplifying that, I can tell that if I did multiply it all out, it's going to be quadratic. Okay. Everybody okay with that? Now let's look at volume. I'm sure you already know what the answer is going to be here, but we're going to look at it anyway. So let's say the width of the bottom is x. We'll say that the length is 6 more than that, so x plus 6. And the height is 2 more than the width, so we get this. Okay. Then that means I'm going to find volume. So for volume, that is x plus 6 times x plus 2. And that would be cubic, because I would end up with an x cubed. So in general, okay, when you were looking at a problem situation, even if you don't have any data, if the data that you would end up getting in a problem situation models perimeter somehow or is something linear, then you'd have linear. That's why it's just plain old units. If you have something that models area, where you're going to multiply two bits of data together, that's when it's going to be quadratic. That's why it's units squared. And then for area, or for volume rather, if you have anything that has volume to do with it, it's most likely going to be a cubic function. And that's why it's units cubed, because you're multiplying 3 dimensions together, you're multiplying 2 dimensions, and you just have 1 dimension. Okay? What questions you got? All right, good deal. Flip it over. Let's get to the calculator part here. So this says a bottle rocket is set up on a picnic table. When the firework detonates, it will shoot straight up and come back down. The height of the bottle rocket is modeled by this height, where T stands for time in seconds, and H is the height for the rocket in feet. So height of the bottle rocket is this function. T is seconds, and H is feet. Paying attention to your units is very important. Using your units correctly, very important. Okay? So we are going to, this is a calculator question, so we're going to go to the calculator. So when you turn it back on, you should be here. We're not going to create a new document because we've already done that, but we didn't do anything with it. So we're going to go to the current document, which is 4. and you should be back here at the graph. Okay, everybody back here at the graph? Shane, you got your calculator? Oh, was it in your lap? I thought you hadn't got it out. Okay, sorry, I thought, since you came in late, I was just making sure. Okay, I'm sorry, what? Okay, are we all here? Okay, good. So we're going to type in this function, but you can't use t, you have to use x. And it's negative, you have to use the negative sign, not the minus sign. Okay, so negative 16x squared plus 64x plus 3. Gael? You need to be typing this in. Everybody got that? And it's on your paper, because I'm about to hit enter. It's the same thing on your paper, you just have to use X's and not T's. Hit enter, you should get this exact thing. If yours does not look exactly like me, since we started new documents, you typed something in incorrectly. All right, we all good? Yes. Got something weird? Okay. Oh, you erased it. Okay, so we're going to start a new document. We're going to add a calculator. Sorry, enter. And then we're going to add another one. Add a graph. Oh, shoot. And then type that in, but use X's. Okay? All right, everybody else okay? Yeah, show your neighbor. Make sure we all look the same here. Okay, so the first question. Yes, oh, sorry. What do we got? It's on the wrong side, so. Oh, you don't have the negative in front of the 16. No, you're good. Okay. Did you get caught up on? Okay. All right, so are we all good here? All righty, now, we have the function. We don't always have to be able to see it nicely, but it would be nice if it was a little bit better than this. So we are going to fix this a little bit. Sometimes you'll be given enough information to know exactly what to fix it to. And sometimes, like now, we don't, but we know what kind of makes sense. We're shooting a rocket up in the air. Does it make any sense to have negative time? Can I start at negative 10 minutes? No, okay. Does it make any sense to have negative feet? No. Maybe if I was like on a cliff and that was where 0 was and then it fell down into the ocean, or if it went below sea level, or I dug a hole or something like that, but that's not what's happening here. So we want to fix this. So we go to menu, where we find everything we want to do. And what we want to do is fix the window/zoom. Now there's times to zoom. This is not one of them. I want to be able to pick what I want to do. So we're going to do one for window settings. Okay. Now, even though I know that there's no negative time, I really don't want my graph, that's just kind of a personal preference, to actually start at 0. I kind of like to see my axes a little bit better. So I'm going to start at -1, just so that I have a little bit over there, but I don't need to actually see anything. And then the maximum, we don't know what the maximum time is, so we'll just leave it at 10 right now and see what happens. So then let's go to Y. Same thing. I want to start at a -1, even though I know I'm not going to actually use the negatives. The height is probably going to, well, I know the height goes more than 6 because it went off my graph, right? But we don't know how high, so let's just go with 100 and see what happens. Okay? And we'll just leave the other things auto. It doesn't matter because we're not going to count on the graph anyway. We all good with all that? Okay. So I'm going to hit enter. Now, the height's probably okay, and even what I see is fine. I wouldn't necessarily have to fix it, but my time, it's way too far. And even though I'm not going to count the little hash marks there, it is to scale, so it doesn't even go halfway. I think we'd be safe changing our x values to 5 instead of 10, and then we could see everything a little bit better. Sometimes it's easier just to navigate. So we'll go back to menu, 4 for window zoom, 1 for window settings, and I'm going to change my x max to 5. Everybody with me? Okay, and hit enter. Then we'll be good enough, right? Everybody good with that? Okay, perfect. Now, the first question asks, it says to find h of 1.25. So that is something that I can let the calculator do. Now, could you substitute that in and actually work that out? You could, right? I mean, we're capable of it, but that'd be yucky, and I don't want to have to do that. I'm not going to trace on my graph because that doesn't give me anything accurate, but the calculator is going to do this for me. But we're going to do it on the calculator screen. So to change back and forth from these tabs, that's what these little blue pages are right here. So we're going to do Control and then left, and it takes you back here, which is where your actual calculator is. Okay, so Control left or right. I don't think it matters. Now, I want this to do it for me. I have this function in my calculator. Where is this function in my calculator? What's it called? Like, what's the name of the function when you typed it in? F1, right? We put it in F1. And it doesn't hurt sometimes, especially if we have a bunch of things, that we have this in h of t. This is actually in F1 of x. You know, especially if you have more than one, you might want to write down to remember where it is. Okay? We only have one thing, so it's not that big of a deal, but have it labeled for yourself so you know where to find things. All right, so what I want is I want h of 1.25, but in my calculator, I want f1 of 1.25, right? I'm just going to literally type that in, f1 of 1.25, and hit enter. It does it all for me. The answer is 58. Everybody good with that? Okay, so I'm going to come over here. I'm going to answer my question. So it says find h of 1.25. So h of 1.25 equals 58. 58 what? Seconds or feet? Feet. Because this is my seconds, right? I substituted in 1.25 seconds to get 58 feet. Okay, so then it asks me, what does this mean in context? Well, when is the rocket 58 feet high? When the time is 1.25 seconds. So I need to say that at t equals 1.25 seconds, okay? So it's not just 1.25 seconds, and it's not just t equals 1.25. It's at t equals 1.25 seconds, the rocket is 58 feet high, or off the ground, or however you want to say it. Okay? Your words don't always have to look exactly like mine do, like if you were wording it differently in your head, but what you do have to have is units. You have to have variables. It has to be correct there. If it didn't ask me in context and it just asked me for this part, then just having this is not okay. This whole thing, you have to make sure that you are expressing what you know very accurately and clearly. Okay, we good? What questions you got? Okay, so then it asks me, what is the restricted domain? Because here, let's go back to our graph, so Control right. This is a parabola. We knew that before we graphed it. The entire parabola does not make sense in the problem situation, right? I clearly have a restricted domain. Where does my domain start? At t equals what? When do we start a stopwatch? T equals what? 0. So we're starting at 0. I mean, I know my graph shows more, but in the problem situation, I'm starting at t equals 0, yes? And I'm going to whatever the t value is here that I don't know. Okay, and now I've done weird things, sorry. So right here, can I find this value? Can the calculator find this value for me? Yes. What do we push on here to have the calculator do stuff for us? First, menu. And then what are we trying to do here? Analyze the graph. And what am I looking for? The 0. If I'm going to do it is where it intersects the axis, but if I'm going to do intersection, I have to have two functions. Does that make sense? So I'm looking for the 0. Now, here's where I cannot model this for you up here because it's a touchscreen board and these don't jive. So remember that this button right here, the middle part of this, that's a little trackpad for you. So I don't know where your dotted line started. Did everybody start right here? No, it's like all over the place. So what you want is you want this dotted line to be on this side of the 0. Okay, just somewhere, not all the way over here, just over here. When it says lower bound, use that trackpad to move your dotted line to where it's on the left side of the 0. When you get it there, then you can click and that little hand will go away. Then it says upper bound. Then you use the trackpad to move it to the other side of that, which again, I can't do because it doesn't work on this board. Move it over here, and then you click over here, and it'll give you your answer. Okay, everybody okay with that? So we got 4.0463. We have to be correct to 3 decimal places. My suggestion is whatever the calculator gives you, write down 4. So we're going to write down our restricted domain. We are going from 0 to 4. Let's see, I forget instantly. 0463. Do I include 0? Is 0 a time that I could substitute into my function? Yep. Do I include the other end? Yep. Good. What about my restricted range? Where does it start? 0. Okay. It also starts at 0. Now, technically, the rocket doesn't start at 0. The rocket starts off the ground a little bit because it's on a table, but it ends on the ground, so my range does start here. So it's going to start down here, and I'm going to use all the y values until I get here. What is that thing called on the function? Maximum. Can the calculator find that for me? Yep, Gael, you know how to do that? Yeah. Okay, so what button do I push? Menu. What am I trying to do? Analyze the graph. And what do I want to find? Maximum. And then you do the same kind of thing with the little dotted line. You got to move it. I wish I could for you. Move it to where, like mine's in a bad spot. It doesn't have to be way over here, but it needs to be on the left-hand side of the maximum, like right there. And then you would click. Then when it says upper bound, you move it over here. You click right there, and then it'll give it to you. This is 67. Okay. Everybody with me? So we go from 0 to 67. The other nice thing about using interval notation is if I use inequality notation, I have to make sure I'm using the correct variables. X and Y would not make sense here. It's T and H. And if you don't use the right things, you might not get credit for that. If you use interval notation, you don't have to worry about what those are. Okay? I mean, you have to know what they are, but you know. All right, so then it asks for the average rate of change for the interval from 2 to 3. What is the average rate of change? What is that in general? Slope, right? So it's the average rate of change for the interval from 2 to 3. I know that that means slope. So I'm going to find a slope. I'm going to find h of 3 minus h of 2 over 3 minus 2. Now, let's look back at the stuff that we have found. Let's see if we actually know any of this already. Have we found h of 3? We haven't, have we? All right, have we found h of 2? We have. What is it? 67. Okay, we didn't write it down like that, but if you look at your graph, when t is 2, h is 67. So I actually do have that one. So this will be something like 67 over 1. Okay? So then I can come back over here, and we want to find h of 3. Do I find that on this screen? No. I find that on the other screen, so I do Control, go over here, and I want f1 of 3. And it's a nice number also. If it was a crazy decimal, we'd save it or do some other things, but we'll discuss all that a little bit later. But you get 51. Then I can come back over here, put 51 right here. This is the calculator question. So you can use the calculator to subtract these numbers so you don't mess anything up. So what is 51 minus 67? Negative 16. Then I need units on this. I had h over t. What are your h units? Feet. And what are your t units? Second. Whatever the units are, you put them. H over t. Sometimes the units may not make any sense to you. If it's monkeys per apple, you write monkeys per apple and don't worry about it. You just pull it straight off the straight off the thing. Okay? It shouldn't get that weird, but sometimes it's something that you, I don't know, don't really process very well. All right, everybody good with all that? What questions you got? All right, so I want you to continue to bring your calculator until I tell you you don't need to for a while. With that said, I did say from the beginning, but I wanted to make sure everybody's settings and stuff are right again. I did say from the beginning, if you're worried about you carrying that calculator around because you think there's no way in the world you're going to keep up with it because you know yourself, that's fine. Leave it at home. You can use one of mine. Okay. I do think it's better if you use your own, but I also don't want you to be losing a calculator. Okay. We're good? All right. So hang on to this. We will finish this tomorrow.